Right. So, good evening, good afternoon, good morning, as per your own respective times. I welcome you all for this evening session, the evening Genesis Tech Talk, which we have launched about a few years back. And I'm pretty excited to bring the 41st edition to you today, the 22nd of December 2020. 2020 year, as you all know, has been pretty eventful in many respects. From an IC's perspective, it has been eventful too, in the fact that we have been able to conduct many interesting tech talks this year. In fact, in all, we did 20, this is the 22nd Genesis Tech Talk we are doing only this year. So, in many respects, I would say that while on one side we have had some challenges, on the other side, IC was very comfortably able to tweak changes and be ready to conduct its regular sessions, regular tech talks, bring high quality events and discussions across multiple different topics, multiple different areas of knowledge to all of its members and its affiliates and partners through the Genesis Tech Talk series this year. And I'm very happy to let you know that Genesis by itself has become a very interesting flagship event, which is being recognized across the globe nearly now. With this year alone, we have seen participation to the Genesis Tech Talk series uh, from across 40 countries, and I think close to about 1,200 members have actually benefited. 1,200 partners, associates, members have benefited from the Genesis Tech Talk series that who have attended these programs. So I'm extremely happy for the kind of response we have seen. I'm extremely happy that we are able to create a lot of engagement, excitement, and connect with the industry at large, and continue to bring high quality events as we are going to witness one today through the Genesis Tech Talk series itself. Today's session is very interesting, and we will soon learn about the topic from Mr. Sasidhar. I'm hoping that this session is going to be as exciting as all of the previous sessions we have seen in the past. And I think we will all enjoy this session being the last session for the year 2020. And I think there's a lot for us to remember 2020, and this one is the last session we are actually conducting this year. So I'm very sure that next year we start with some more exciting similar such topics, interesting topics around civil engineering per se, and bring you some very interesting discussions going forward. We continue to receive a lot of interest from various organizations, various professionals across the globe in partnering with us and attending these kind of sessions. As you see on the screen right now, nearly 15% members, sorry, 15% professionals who join our sessions, they are not even members of IC and they still join us. And they have actually time and again expressed interest to join with us. And this presentation is actually focused in getting them connected, helping them out to figure out how they can actually participate. I'll be sharing my contact details with every one of you. If you're interested to know more about IC or would like to become a member of IC and participate in any particular fashion, feel free to do so, and I'll be more than happy to engage with you and help you understand what IC is doing across the globe, especially within the Mumbai region. Talking about IC and IC Mumbai, I would just like to remind you all that IC is a global organization with more than 95,000 members across the globe, across 162 countries across the globe, and it's been around for more than 200 years. So it's a very very old organization, very highly reputed organizations. For the quality of members that it brings in, for the quality of programs and events that we conduct. And I'm very proud that Genesis Tech Talk has been able to live up to the reputation of IC. So benefits of membership, as you would expect to see, events like Genesis Tech Talk, we have been conducting conferences, we have been conducting various mentorship scheme, and we are actually providing a lot of mentor support to professionals who are aiming to become chartered, professionally qualified through ICE. And we have got number of members who are mentors. I'm probably sharing some information about that too. I see benevolent fund is a very interesting concept. Again, I think people who need help, financial help, because of various problems that they have been facing globally. Once you're a member of IC, you have the access to the fund. So I think it's a great source available for supporting people who are struggling either financially or for some other reasons. And I think as a member of IC, you will be able to avail a lot of benefit becoming a part of the IC and availing these benefits. Uh, Moving further, there are typically there are 5 grades of memberships, and one grade that's missing over here is the associate membership. I'll briefly talk about that too. You can engage with IC being a student member immediately after you're a past student. You can become a graduate member. Subsequently, work towards becoming a chartered member or a full member of ICE, and the highest grade of membership currently existing is the fellowship. So feel free to engage with me if you want to learn more about what each of these grades would mean to you and how you can engage with me with IC through IC and achieve your professional goals using IC as a platform. Feel free to reach out to me, and I'll be more than happy to engage with you. So people who are not engineers but are CAD designers, CAD technicians, they can become professionally qualified as technician members, as Eng Tech members of IC. So feel free to reach out in case you're interested becoming an NSTEC member as well. But again, let me remind you that membership of IC is extremely prestigious, globally recognized across multiple countries, and I think there are a number of countries which are availing special benefits to members or professionals who become professionally qualified through IC. So the reputation is really very strong. It means a lot within the industry itself. Uh, that's the team that I have right now. The committee members of IC are very highly reputed professionals within the industry. As you see, some interesting stalwarts from various consulting houses as well as construction industry are actually a part of my committee, and I'm really very proud to have them on board. They are actually looking at I mean, practically all the thought leadership that exists in the industry is actually available within our own committee, and I'm very glad to have some of these stalwarts participate and contribute to thought leadership. They are the think tank and actually contribute in many different respects, and I'll probably quickly share through this particular slide. So I'm pretty glad that each one of these leaders who are committee members, they are leading some or the other initiative within the IC Mumbai specifically, and some of them actually are leading India-wide initiative. For example, Sindhu Nair, she leads the Women in Engineering Initiative for IC India, and I'm pretty glad that we have seen a very interesting traction and significant synergies across multiple different companies in India who have expressed their view, who have expressed their willingness to contribute and participate and be a part of the IC India's Women in Engineering Initiative. Apart from that, we have professionals from Tata's, we have professionals from Stoop, we have people from Bureau Happold. I myself, I work for Black and Veatch, and we have different people across Ramball, Arcadis, and other very reputed consulting houses, and they are actually trying to lead various initiatives spanning right across innovation and incubation to creating design workshops for training support and looking at academic partners and collaborating with the industry uh, and looking at events like how we are doing right now, the Tech Talk events, making sure that we bring the highest quality content to each of our members and the fraternity at large. So being relevant is very important, and we understand the importance of being relevant. So as I said, Genesis has actually by itself become a very an important flagship event, and we are able to touch professionals across 40 different countries only through this single event. And we have been able to cover subjects ranging from business excellence right up to innovation, up to bridges, tunnels, and practically everything under the roof when it comes to civil engineering. So I'm really glad that we are able to bring extremely diverse topics under the Genesis Tech Talk. And I'm only seeing that the patronage to this particular event growing over a period of time. Likewise, we also conduct various site visits. I'm very glad that the Tech Talk that we are actually hosting today, we have already done a site visit last year, and I think some of our young professionals were super excited to see how things were built, to see things being built in person, and actually really gain a tremendous experience out of being on site. So I'm really glad that we did this site visit, And as a follow-up, actually, we are also doing this very interesting tech talk, and I'm very excited about this lecture itself. Um, so as I mentioned, we are doing the Women in Engineering initiative, and there are multiple different things that are happening within Women in Engineering. We understand and appreciate the importance of diversity and inclusion. And I'm pretty glad Sindhu Nair is actually leading this. She has got a very, very energetic team of 16 odd professionals across various companies who are supporting her, creating a vision, creating a mission out of the Women in Engineering initiative, and try to achieve something meaningful through this particular initiative. So again, extremely happy that we have seen some traction, and I would be encouraging every single professional who is interested to be a part of the Women in India initiative and contribute in any respect that you would like to. So those are my coordinates. I'm based out of Mumbai. So if you are interested to talk to me, want to know more about IC, and want to become a member of IC, or would like to see yourself professionally qualified, feel free to reach out to me. There are 3 approved mentors who are able to support you to become chartered members of ICE. I am one of them. So if you need any help, any support, feel free to reach out to me, and I'll be more than happy to help. So let's talk about today's session. Today we have Tech Talk. Again, the subject is all known to you. This is the tallest statue in the world. Of course, it has been pretty controversial in some respects, but I think as an engineering problem, I really see this as a very interesting engineering problem to solve. And we will be all ears to Mr. Sasidhar, who is actually going to take us through the challenges and how his team mitigated these challenges, and hear out hands-on experience that he would like to share with us today. So over to you, Mr. Sasidhar. Please take the baton from me. Thank you.
Yeah, thank you, Mr. Rajesh, for a quick introduction.
Yeah,
First
thanks.
of all, good afternoon, good evening to all the participants who has joined from different parts of the world. It's my pleasure today to present on Statue of Unity. In fact, I was there in this project from day of first day to till the project was commissioned on 31st October 2018. I will I have put a lot of slides covering almost all topics of the project, but I will try to do justice of most of the topics. So I will take you all of you to various aspects of the project with respect to design and construction. So it's our first point to introduce the team. The client is Sardar Vallabhbhai Patel Rashtriya Ekta Trust, Gujarat government. And then we have the PMC Turner Construction, Turner Project Management, and then the structural consultant is Manhart. And they also did the MEP. And Michael Graves from US is the architect from. These are all from the client side. And we actually appointed Arup UK as our prime designer for the statue. Now, when we put different statues in one slide and see how this particular statue looks like. So right now it is currently 182-meter tall, and this is the tallest statue. In fact, we started working on Chhatrapati Shivaji Maharaj Memorial, and in 2018 we started, and then it stopped because of certain reasons. And presently there is no work going on. Otherwise, that would have been the tallest statue, which is around 212 meters. The major milestones in the project is that we did the complete design and construction in 46 months, starting from December 2014. The design lasted for 13 months, and the casting of foundation happened in December 2015, and we completed the course for the main statue in December 2017. After that, we were left with only 10 months for complete structural steel and bronze erection, and we were able to inaugurate on 31st October 2018 as per our Prime Minister agenda. So I'll just brief on the location and how the project works. This is the Narmada Dam in Gujarat, and this is the downstream side of the dam. From about 3 kilometers from the dam, we have this small hill on the downstream side of the river where the statue is located, and we have to construct a bridge to approach the statue. And 5 kilometers from here, on the left side, you can see here there is a hotel which we built, which is having is a 4-star facility hotel. So the idea is people come to this place, they get down here and take a boat, and then you navigate along this river in opposite direction, and then go here. and then take a turn, and then get down here, and then travel, and then walk along the bridge and get inside the statue. This was the original plan, but when we completed the project, there were a lot of issues about the water depth available. So there were a lot of construction works to be done. And I hope now by this time, this river navigation is ready. So people can experience that particular route and then come to statue here. And people can go in return by taking the road. So this is how the project was thought about it. And if we come to this place where this is a statue, and this is approach bridge, and this is a jetty, a small platform which we constructed here, where people can come through the boat and get down here and take a ramp and then come up and then walk through the bridge. And this is the 3D perspective view of the same thing, where you have the statue. This is the memorial building. And when you walk inside, you will see a lot of artifacts kept, a museum created inside this space. This one slide will explain the complete project. So the total height of the statue is 182 meters. When we say statue height, across the globe, people take measurement, both the pedestal as well as the statue as statue height. So for this particular statue, it is 25-meter pedestal height and 157 meter the statue height, which comes to around 182 meter. Now out of this, at around 135 meter from the foot level, we have a viewing gallery which we created, and the viewing gallery looks something like this, where people can go and take a lift through it goes through the leg, and each core has a provision of lift. 26 persons can travel through this lift, and they can reach to this level, and then you can go and see through this viewing gallery. We have created a unique feature in the viewing gallery where people can see from the front side of the statue, you can see the dam, and on right side of the statue, you can see the downstream side of the river. So this is how the entire gallery was created. This is completely air-conditioned gallery which was created. I'll play a short video of 7 minutes so that you can see how the entire statue was done.
71 years into independence, despite the obstacles in its way, India has clearly chosen the path of unity. When the British left India, there were 565 princely states with the option of joining India, Pakistan, or remaining independent. The mammoth task of integrating each princely state with the dominion of India fell upon the shoulders of one man, Sardar Vallabhbhai Patel, our first Deputy Prime Minister and Home Minister. He made the impossible possible. History called him the Iron Man of India, the great unifier. Fittingly, his birthday on 31st October is marked as Rashtriya Ekta Divas. It has been a long-standing dream of our Prime Minister, Shri Narendra Modi, to pay tribute to the great Sardar Patel.
एक तिरंगे झंडे के नीचे हिंदुस्तान देख रहे हैं, उसका श्रेय सरदार वल्लभ भाई पटेल को जाता है.
On 31st October 2013, Shri Narendra Modi, the then Chief Minister of Gujarat, laid the foundation for the tallest statue in the world, the Statue of Unity. In keeping with its ethos, L&T took up the challenge head-on. Located on Sadhu Bed, 3.2 kilometers from the Sardar Sarovar Dam on the Narmada, the Statue of Unity is an unparalleled confluence of engineering and art. Although L&T had successfully completed a plethora of prestigious projects, including power plants and commercial complexes, a structure of such scale was one of a kind. The honor of sculpting Sardar Patel's likeness went to Padma Bhushan awardee Shri Ram Sutar. The first challenge was to select an apt pose and expression to do justice to him. Although L&T's role was that of an EPC contractor, they still took active interest in the selection process. Extensive discussions with historians and experts ensued. After sifting through thousands of photographs, the team was unanimous in how the statue should look. Sriram Suthar created sculptures in varying sizes, honing every detail again and again. The latest 3D scanning techniques and computer-controlled production ensured accurate reproduction of minute details. Immense statues the world over have a broad base to achieve structural stability. Sardar Patel's statue was slated to be the tallest ever, and the greatest task was to achieve the design. His dhoti needed to end above the ankle. He is in a walking stance, thus the feet were not parallelly aligned. The assertive stride meant a gap between the feet. But the L&T team was equal to the task. Operations commenced in 2013 with exhaustive surveys of the land, riverbed, river and wind. This was followed by critical engineering design, a test of L&T's experience and technical capability. In such a remote location, planning and logistics would be the key to all the operations. The Loha campaign was launched in earnest with a view to employing used implements donated by farmers around the country as a symbolic tribute. This iron forms the steel rebar in the raft foundation, a homage to the Iron Man of India. A reinforced concrete core, created with critical concreting methods, gave the structure a stable base. This would support the primary and secondary steel trussing. The bronze plates then covered the entire structure, forming the sculpture. Locally available sandstone and Baswara marble has also been used. Besides the statue, other key elements like the memorial and visitors center, main access bridge, bridges and roads were made to precision. The Shresth Bharat Bhavan is a 3-star facility for the tourists and guests. To bring socio-economic development to the region, students and vendors from nearby villages and towns were also trained for the project, thereby generating ample employment. The ultra-modern BIM technology for the design and project monitoring brought synchrony between the team and 30 consultants globally. The statue houses two 200-ton suspended tuned mass dampers to make it stable enough to withstand violent winds plus seismic activity. L&T created macro panel assemblies on site for the smaller micro panel bronze castings. This ensured speed and seamless assembly. Every plate was unique and RFID tagged and bolted in its place. As work progressed at blazing speed, the engineered structure transformed and the statue began to take shape. Designers, engineers, experts, specialists and workers from different parts of India have toiled night and day in a united effort unto one goal: the Statue of Unity. Colossal enough to remind future generations of his epochal contribution. A structure as enduring as the vision of modern Indian nationhood. As Sardar Vallabhbhai Patel himself said, mankind without unity is not a strength. Only when harmonized by unity does it become a spiritual power.
That was a very short video on which will show the complete glimpse of the project. Now I will take you further on various aspects. So the entire project was designed to handle around 15,000 visitors per day. But after inauguration in 2019, we came to know that the visitors per day in peak days, like festivals and weekends, the crowd used to come more than 30,000 to 40,000 was the range. So already the facility started cramped. And the viewing gallery was designed to take passengers, 2,000 passengers per day. And it was not designed to take all the visitors to the viewing gallery, only specific number of visitors, because of the limited provision of lift inside the statue. And the statue is designed for a wind speed of 180 kilometer per hour speed, and it was designed for zone 4 earthquake seismic zone. And this is how the topology looks like when we did a complete bathymetry survey, topography survey, and various types of surveys to merge all the details to see how the riverbed looks like, how the contour looks like, and then to take appropriate decisions on to study the water flow effect on various embankments. And the work started with cutting of the hill to level the hill to reach the foundation level. And these are all some of the photographs. And now coming to deriving the statue profile, this is one of the most important aspect of the statue. How do we derive the entire profile of the statue, which is from a 6 feet height person to 157 meter height. So something which is unique. So each and every detail of it has to be developed in a systematic way. So the entire process started in 2014 August, and then it concluded somewhere in May 2017. So it is multiple steps were followed. So initially we were given a particular posture, like the posture which was available outside the Ahmedabad airport, where the Sardar Vallabhbhai Patel is in a walking posture. So that posture was given to us to start with the entire design. So then the various meetings were conducted to see how the face should look like, how the eye should look like, how the lip should look like, how the wrinkle should look like, how the head should look like, and each and every aspect was to be detailed in precise. And this is the photograph which was given to us, and based on this, the sculpture has developed various models, and it started with a 3 feet height statue in 2014 October, and then we went to 18 feet statue, and then we went to 30 feet statue, and then we did in the 30 feet statue, which was done in 2015. We got principal approval of the face, but however we required a lot of corrections in the face, and then we did a 1:5 scale foam mock-up in 2016. This is the 1:5 scale mock-up, and this is the same head which is actually kept inside the in the base of the building. So later on, certain corrections were done in October 2016. Some more corrections done in November, and then finally in January 2017, this was finalized. And then we finally came up with the actual bronze 1:5 scale face, and this was finally moved to the museum where it was displayed. So it was an elaborate exercise to arrive at the face and how the expression looks like, and each and every aspect of the character of the face. It's not only about the face, each and every parameter of the entire body, like how the shirt, the shawl should look like, how the dhoti should look like, how the various parts of the body should look like, how the button of his jacket should look like. And this is the 1:1 scale foam model of the face front view, which was done in the factory where the bronze was cast. And based on this, the molds were created, and then the actual panels of the bronze were casted. So this is the 1:1 scale mock-up of the face, which was done in the factory. And then it was completely assembled and checked, each and every panel is matching. And then it was cut, dismantled, and then shipped to India. And then finally it was again assembled. These are the left side pictures are assembled at the site, and the center one is assembled at the factory before dispatch. And this is the right side one is after erection at site in position. So these are all done at a different times, and then and put in a one slide to show how the face looks like. And we also did a study on how the statue will age and how the statue will change its color, because it's a bronze, and we have not given any coating to the bronze. It's a natural finish that we have given to the bronze alloy. So in a natural finish, it will form a patina, and it will change its color from this brownish color, and it will change over period to greenish color. It is exactly similar to what Statue of Liberty is there now. Right now in USA, you can see the Statue of Liberty is completely greenish. That is because over a period of time, the alloy will change to greenish. So this particular alloy also will change to greenish after certain years. So basically this alloy consists of copper 88%, tin 8%, and zinc 4%. So this is how the composition. The tin is basically added for strength. And coming to the actual design, so we were asked to design the structure for 100 years design life. And when we say 100 years design life, there are few codes which talks about 100 years design life. And when we say 100 years design life, each and every material, the selection of material and its use is very, very important, and defining the durability of the materials is very important. This is where the experience of the consultants comes into place to define what kind of grade of concrete, what kind of steel, what kind of coating for the steel you need, and what is the cover. All those parameters are derived based on the 100 years durability requirement. So these are all some of the parameters which we have used to arrive at the 100 years design life. So ultimately, we had to use 50 millimeter cover for all structural elements to ensure that there is no corrosion of rebar happening inside within this 100 years design life. And now the structure is designed for 50 meter per second wind speed, basic wind speed, when the code says it is 39 meter per second. So ultimately, there is a inbuilt factor of safety of 71%, which the structure carries out. And when it comes to seismic, as per the code, it is zone 3, and whereas we were asked to design for zone 4. Again, here there's a 50% redundancy in the design. Now, the most critical part of the design is the ankle. So we don't have sufficient stiffness at this particular location, as the ankle is completely exposed. So we had to use this cross section very effectively to transfer the complete lateral load as a moment at this particular location to the statue base. So that was the challenge given to us. So if you see this is one particular slide where you can see the gap between the concrete surface and the bronze skin. We hardly kept around 600 millimeters to 500 to 600 millimeters here. That was the only gap available, and that gap was used to fix this panel with a minimum steel, so that it can go and fix as a panel. So the entire cross section of the leg was used for generating the stiffness of the structure, so that we get the required strength. But however, what happened is when we checked the structure for wind tunnel analysis, and then taken those, we did this wind tunnel testing in Canada. RWDA has carried out the wind tunnel test in their facility, and when we got the first set of results, we found that the structure is not capable of transferring the force at the ankle level because of very high level of wind. So then we came up with the provision of using tuned mass damper, and by using tuned mass damper, we have increased the damping of the structure to 4%, and reduce the structural wind loading on the statue by around 30%. So this is how the effects of wind were taken up, and the strength of the structure is accelerated by adding this tuned mass damper. So we have used two numbers of tuned mass dampers, and these are installed at above the chest level on top of the concrete core, and each weighs about 200 metric. These are all pendulum type tuned mass dampers, and there is no electromechanical here. It's when there is an event, it will activate. So it's a simple viscose type damper we are used. And when it comes to the structural idealization, we have the two cores going up to the above the chest level here, and then these two walls are connected with the coupling walls. The core walls are connected with the coupling walls up to the gallery level, and this starts above. Since there is an opening here, this coupling wall starts somewhere here, and then it goes up to the viewing gallery level. And once that is formed, then the skeleton of the statue is formed using the primary steel. The primary steel is divided into these 5 segments. We have a upper leg, and then we have the lower body, then the upper body, then we have the shoulder and head portion. So now if you see, these are all disconnected. There is no connection between this piece to this piece, this piece to this piece. We have completely isolated this so that all these do not act together. So when there's a sway, there is no much of movement within these two, and all the bronze panels will be within the limit. And each bronze panel is again have its own movement when such kind of wind or seismic activity happens. So we have used concrete grades of M60, M65 for the main statue, and 40 M40 for torsional slab, all the slabs, and then the TMD slabs M50. And generally the entire grade of steel is structural steel used is 350. And cladding, the bronze cladding is 8 millimeter thickness. And this is the foundation pad which is used for the main statue, which is 34 meter by 44 meter, and the thickness of the raft is around 3 meters. So it's a open foundation on which the entire statue rests, because we have very good rock. 750 tons per square meter is the strength of the rock. So these are all some of the photographs of the raft in the initial stages of the project. And over the raft, we have a big wall, which we call it as a drum wall. And inside the drum wall, we will have these 2 cores which are coming out. And you can see some of these photographs where we had to construct a temporary bridge, a bailey bridge, so that the material can be transported here, because the main bridge could not get ready during this construction time. So some of the logistics during the foundation casting. And we had to do a lot of leveling of the hill to get the desired shape, and a lot of mass filling of concrete here. We did a lot of CLSM concreting here, and then over this the entire museum structure comes here. And we had to do a lot of measurement, a lot of care to reduce the heat of hydration in the concrete. A lot of care was taken because huge mass concrete was done. So there were several aspects were taken care in concreting of concrete. Especially we used to do in the night time. A lot of ice was added to concrete in the batching plant, so that to maintain the temperature at a lower level. And this is the typical cross section of the statue below the feet. So this is the drum wall, and these are the 2 core walls. And this is the cross section if you cut somewhere at above the legs. And so these are all the cores, and we can see here a provision of lift and staircase inside in each of the cores. And at every 11 meters, we have a connecting slab here, connecting the 2 cores. And during any emergency, people can come out through the staircase, and they can go from one core to another core uninterruptedly. So these are all the safety precautions, and then as per the life safety norms, the structure has been designed. And this is a model of analysis model which was done in GSA by Arup. Arup did the complete design of the structure in GSA. And if you take this particular core is a very special design which Arup did it. And how they did is the entire cross section of the core is fed into the coordinates of the core are defined in AutoCAD, and then the coordinates are fed into ADSEC program, and then the bars are defined. And once you define the bars, and from the analysis results, we take all the forces and then check the capacity versus the force. And when you plot the graph, all the pink color, all these dots, whatever you are seeing, these are all the forces, and the blue color is the capacity. Now, once all these dots are inside the blue color, that means this has enough strength to take care of different combinations, different forces, and it is safe for taking each and every aspect. So that's how the entire statue is designed using this particular concept. So some of the photographs of the statue base during construction. And we used a foam liner, and we have put the liner inside the shutter, so that the entire perimeter wall on the statue base looks like which gives a rock finish. And we actually painted over this with a brownish color, so that it looks like when you see from a distance, it looks like a rock finish. So these are all certain things which we have used. And now coming to the the main portion of the statue, that is the how to erect a statue. We had very limited space. It's a small hill. We cannot do scaffolding, so we had to use only tower cranes. And we have put one tower crane on the back of the statue, one tower crane in one of the core. So these are the two tower cranes we have used to do the complete erection of steel and bronze. And this is how the reinforcement inside the core looks like, very congested, lot of bars, 32 dia bars, 28 dia bars, and a lot of embed plates to fix the steel. And these are all some of the photographs. Basically the jump form work was used to take the cores up. Initially the cycle time for one lift was around, we started with around 30 days like cycle time. And then when we did the final pour, it was we were able to reduce to 7 days cycle. That's all. So there were a lot of steps which we have cut down to, and a lot of standardization we have done to reduce the timeline and reduce the cycle time for the taking up the core. And this was the last core which was taken up. And if I take a slice of the structure, slice of the body of the statue, this is how the steel looks like and the cores looks like. And we have two cores here connected between the two cores with a slab, and then we have the skeleton of the steel, and then we have the girders. These are all called wind girders, and to these wind girders, the bronze panels are hooked up so that the bronze will transfer wind load to this wind girders, and then in turn it transfers to the core. So that's how the structure was designed. And now these are all some of the photographs where we can see the various parts of the body. Here you can see a lot of staircases and platforms were given inside, so that the statue can be maintained well from inside, so people can go inside and see each and every part of the body. If there is any rectification done, any bolt is loose, you can tighten it. So complete provision of platforms are given. You can see here the staircases and platforms are there at each and every level connecting this. And the entire structure was galvanized. It was galvanized at one place. It was fabricated at one place, galvanization at one place, and after galvanization, again the material was taken to the factory for further painting. In fact, it is a dual painting, so we are assuming that this will give at least 50 years life for the painting. So that's the level of protection that was given to this particular element. Some of the photographs during erection of bronze and steel. And the next element is the bronze. So the bronze is, we talked about the alloy. So there are totally 550 number of macro panels. So each macro panel is made up of 9 small such panels, and they're all welded. And each small panel, the micro panel is 1.83 by 2 meter. And this panel is actually cast. If you see here, there are 9 panels here which are welded vertically and horizontally. And each panel is actually cast in the factory and then brought to India. And we assembled these panels and then welded with the same alloy, and then made it as a one single panel. And you can see here, this is one of the panel which belongs to the waistcoat of the statue. And you can see the texture, how it was created. These are all manually created on the foam model. And then when you take the mold, then when you pour molten metal inside, you will get this shape. And these are all the testing samples, which were each and every piece was tested for strength and chemical composition. And globally, all the statues were built by providing scaffolding from bottom to top. And this is Shiva temple, which was under construction a few years back in Jaipur, in Rajasthan. So if you see here, everywhere it is fully cladded, and from outside people used to do. And whereas for this particular statue, there is no scaffolding provided. Everything is the entire structure is completed using only the tower cranes. So this is how the entire panelization is done. This is one of the most complex activity. How do you divide the panels? And the panel weight has to be the panel weight, and the steel which is on the backside of the panel should not be more than 8 tons. That is the lifting weight of the capacity of the tower crane. So we have to limit each and every panel weight within 8 tons, and then do the panelization. So some of the panels had a lot of openings, so that there is a ventilation happening inside. So there is a air passing inside. So we have provided a lot of openings for various panels, like the concealed areas and areas in the ears. There are holes, and there are certain locations where we have provided maintainable hatches here, so that people can come down and and clean the surface. And if you see, this is the shovel, bottom of the shovel, how the threading work is done, so that in fact this each thread height is almost 2 feet height in reality. So each and every item is very precisely done, and these are all during the erection time, and these were later on, these were all taken to the position and fixed properly and closed all the gaps. This is a viewing gallery which we talked about, and this is how the viewing gallery inside looks like. So this particular texture is created in such a way that from outside it doesn't look like a big opening like a window. So it looks like a very coarse mesh, and when you go inside, but you can have very clear clear window, you can see through. So that's how the entire panelization was done with respect to this viewing gallery panel. You can see here is a long shot of the statue, but if you don't see big openings in this. And you can see here there are certain locations. These are all certain locations where there are openings kept for the clean air to go inside the statue. And this was a testing which was done in the lab to show that the panel can withstand that much amount of wind, and water testing was done so that the joints are properly sealed. And this is one particular idealization of how the design of the panel was done, how the steel looks like inside. Each and every panel is unique in nature with respect to its shape and geometry. So every panel we have to analyze and design separately, how the shape based on the shape of the panel, and how the steel on the backside will get fixed to the panel. So I'm showing one or two examples of how the shape looks like, very complex. And we used an element called a prop with an adjustable handle in the center. So when you turn this turnbuckle, it has threads on both the side, and it can go in, go out. So the gap can be adjusted here. So this is the item which was used so that we can adjust the small gaps between skin and the steel. So this is how the entire statue was attached with the between the bronze and the steel. And more importantly, we have a Teflon washer here, because there should not be bimetallic corrosion between steel and bronze. So we have put every joint a bimetallic separator, corrosion separator, Teflon washer we have kept. And this is how the typical bronze pre-assembly looks like. So these were the panels which were stacked in the yard before the panelization, the pre-assembly. So we did pre-assembly of each and every. We had around 25 levels of the entire statue, which is sliced for 5.5 meter height. Each slice is 5.5 meter. So this is 5.5 meter height, what you are seeing here. Now this is one panel. This is one panel, and this is one panel, and this is one panel which will go for erection. And this is one level of the panel below the kurta portion. It was done reversed way to support this curved portion. And this was the very complex portion of the pre-assembly which we have done. And you can see here, this is the foot, and then this is the button of the waistcoat and the texture of the waistcoat and the steel on the backside, and then see how the details of the nail and then the folds here. Each and every aspect of the statue was detailed to the highest level of accuracy, and each and every detail was approved by the sculptor Ram Sutar, and the same thing was done in each and every location. This is the portion of the face, and each and every element was taken through the trucks. It was around 3 kilometers from the place where we have assembled to the site location. It was 3 kilometers, and then you can see the panel erection. And this was the most complex portion of the erection of the statue, the head portion. And these are all certain slides related to bronze and the steel erection. Some of the slides, some of the photographs during night. And this is one picture. If you see here, the entire face is outside the center line of the body. It is completely outside. each and every node, positioning each and every node of the structural steel was a challenge. So this was the entire erection of the steel was done by contractor Eversandai, and they have done a fantastic job in aligning the structural steel and to the last millimeter of accuracy, and we didn't had any problem in the assembly of the face. So this, as the steel was done very accurately, so we could assemble all the panels. Now, one more important point, you can see one spiral staircase going through here, one spiral staircase. So this is the last element which will connect to the top of the head. And on the top of the head also, we have one openable hatch. So from the openable hatch, the person can come through a rope system and come down, and that was given for the cleaning of the statue. So each and every corner of the statue inside can be accessed through various platforms and staircases. And we also installed a health monitoring system parameters like measuring the displacement of the statue. And then we have installed accelerometers at various levels. We have installed strain gauges. So these are all part of the system, so that we know how the system is behaving, and whatever we have, whatever parameters were arrived during the design, whether they are remaining same during the life of the structure. So these are all connected. Finally, the entire measurements will be connected to a computerized system, and it will be continuously monitored. These are all some of the photographs during construction stage. Some of the photographs. And all these photographs were from my library. Whenever I used to go to site, I used to collect a lot of photographs. So I compiled these photographs as part of my library. And these are all the joints. Now you can see here during the pre-assembly and all these joints. And then we did shot blasting of the panels from outside at site. We used a copper slag for shot blasting. And all these joints over a period of time, they will merge with the skin of the bronze. When we erect this panel, these lines will be visible for 6 months to 1 year, and then after that they will fade out, and all these joints will merge with the color of the bronze. That's how it will behave. So this is the viewing gallery portion of the statue, which was pre-assembled at the ground level. And this is the riverbank protection which we did, where we planned here the jetty, a small jetty for and when people come on board, and then people will come up like this, and then travel through the bridge. So a lot of protection works were done along the river so that the structures are safeguarded. And I think this is the last slide. I think I have done. I was pretty fast, but I have got almost all the aspects of the design and construction.
Right, absolutely
Thank you.
wonderful. Yeah. Thanks a lot, Sasidhar. I think it was fabulous presentation. I really enjoyed it. Enjoyed it a lot. I would now request you guys, everyone, to type their questions in the chat box, and I'll be more than happy to share those with our speaker today. Maybe while we wait for some more questions to come to the chat box, Sasidhar, maybe I can start with one question myself. Since you have a pre-assembly for one lift of height, which was 5.5 meters, which is what you mentioned.
Yeah.
So you actually get a good understanding about what's happening at one level of 5.5 meters height, making sure that all the joints are matching and so on and so forth. How did you ensure that it matched vertically as well? Because I think that becomes a challenge, because you have already erected something and then there's something else coming on top, which is actually going to be shipped to you later on, and then you will be pre-assembling it. And again, so the pre-assembly is actually giving you the alignment in terms of the horizontal arrangement itself. But when it comes to a vertical arrangement and alignment, how did you ensure that there was no mismatch over there, and you did not have last moment challenges to to deal with when it came to vertical alignment?
Actually, what we did is we did a lot of survey and the team was told that at what stage we had to do survey, and the pre-assembly of the panels was done in a very systematic manner, so that the deviations are very minimum. And I forgot to inform one point is the gap between the two panels is around a minimum 8 millimeters. There is a gap between the panel, both horizontally and vertically. So all the panels are disjointed, and this gap is actually filled with backer rod and sealant. So we have filled the gap from inside each and every panel on all four sides with the sealant. Now we have given an allowance of extra allowance of another 6 millimeter, so that the gap can be 8 to 16 millimeters. So that if it goes beyond that, then the gap will be more. So using the survey, we could actually control the gaps effectively and ensure that it is maintained well within that 8 to 16 millimeters, both vertically and horizontally. Of course, we had problems initially in the first two levels of panel erection. After that, it was streamlined.
Right, absolutely. And for a project of this scale, especially this kind of complexity, and probably there's going to be a first of its kind project. The challenges associated with space and health and safety for workers, especially the kind of free height that we are looking at. Any special arrangements that you made to deal with the health and safety, making sure the access, as you covered a few parts, of course, where you maintained the minimum gap between the external shell of the brass portion with respect to the structural elements. So you had enough, at least 2 feet space, working space available. But from when you actually are performing erection, you of course need a lot of space, and especially the kind of structural arrangement we see, which is very complex. There are elements coming from all different directions and so on and so forth.
Correct.
So did you have to take some special care in terms of either training your workers, making sure that they understand how they are going to do it? Was there significantly different kind of challenge over here vis-a-vis your conventional tall chimneys and stuff that you have been building for the last, I don't know how many years?
Yeah, here the first challenge is that we have to ensure the weight of the panel is within the capacity of the tower crane, and we have to ensure that the tower crane hook is at the desired location so that it can lift the panel, and ensuring that particular place where to lift the panel was one guiding factor. And once that is done, there is no person standing outside the statue. Okay, so the panel is lifted by the tower crane, and only people are inside the statue to receive the panel. So once the panel goes to the position, and then people will pull it inside and then position it and then bolt it. So there is no person outside the statue standing at any given point of time. So there is no scaffolding provided anywhere. In fact, the scaffolding was provided only at the foot level to do certain activities. Otherwise, there was no scaffolding anywhere.
Wow, that's pretty cool. So there are questions in the chat box. I'll probably go through a few of them. What was the stiffness of the statue structure, and what was the natural frequency of oscillation? I don't know whether you are able to provide that kind of detail right now.
Okay. In fact, I forgot the numbers, exact numbers, but it is a tall structure. So the period was long. The period was long. The period of the structure was around 3 seconds, 3.5 seconds. So in both, but the statue was stiffer in side to side direction. Side to side direction, statue was very stiff. We had problem in front to front direction, front to back direction. So that's a direction where it is less stiffer. So so what we did is when we had problem, we actually had problem in the front to back direction to manage the wind load, and in that particular direction the wind load was much heavier because of the exposed the surface area which is exposed from the statue is more in the front direction. So to cater to that particular aspect only, we had to provide the tuned mass damper, which was designed for 4% damping, and then the wind load was reduced. What we were told is generally when the wind tunnel test is done, Typically, the internal test is carried out with 1.5% damping for a general concrete. Now we had to jack up the stiffness of the damping of the structure from 1.5% to 4%. So for that, the twin mass damper was done. And in fact, I can reply to Rouser separately what exactly was the frequency of the statue.
Sure, no problem. It does make a lot of sense, definitely. I mean, of course, in the lateral direction, you get coupled walls as a big advantage, and therefore the stiffness will be much higher than the frontal one. Uh, so we have another question over here. What's the maximum allowed displacement at the head level?
This is a straightforward question. So code allows me up to a certain level, h by 500. In fact, so whatever is a h by 500 for that level, that was maintained, and we didn't had much of problem in deflection. I think it was around 400 millimeters we were getting. It was well within the limit.
I mean, since we are talking about displacement as an interesting topic of discussion, since you have a viewing gallery which is nearly at the chest level, and I've been there, it looks amazing. In fact, the experience being there is amazing. The wind speeds are pretty high over there. In fact, you can feel the wind when you're actually in the gallery itself. I was wondering whether there is some kind of warning system where if the wind speeds go beyond a certain limit, you stop letting people in the
Yeah. So we have as part of the health monitoring system, we have anemometer installed. So we will come to know what is the wind speed at a given point of time, and we have given a document at what particular wind speed you have to stop the operations. So beyond certain level, the operations will be stopped.
So currently, the operations have been handed over to the trust, or L&T is
No. As part of the contract, L&T is supposed to do maintenance of the statue for 15 years. So
right.
we have appointed our agency is there who is actually maintaining the entire statue. So we have people there who does the entire inspection of the statue inside, outside, and do maintenance day in day out. So we will be there for 15 years.
Wow, fantastic. There's another question. Okay, right.
What was the size of the model used for wind tunnel? I think it was 1:300 was the size of the model.
Okay. In the statue, you have shown whole truss assembly was divided into 5 parts to reduce show. But how did you make the structure behave monolithically as truss arrangement was not getting connected?
Okay, I think Mr. Atul was asking about the main steel which we have done in 5 parts. However, what happens is the gap between the 2 parts is 5.5 meter. So the bronze panel height is exactly 5.5 meters. So the bronze panel will go and get attached at bottom to one level and top at one level. So that continues the structure.
Right. Okay. Then there is another interesting question. How did you manage construction during different seasons?
We never stopped the construction, but in the initial stages we were few hiccups with respect to crocodiles and some local agitation. Otherwise, we never stopped the construction. It was running almost all the days, and only there was one particular monsoon when the dam gates were not installed. The dam gates were installed, I think, in 2017. So in 2015 and 16, still it was a year. So the dam will overflow when the full water level comes in. So in that particular season, around 10 days, we could not work because the full water was flowing inside the river and we could not access the hill. Otherwise, apart from that, we never had any issue with the construction. It was going 365 days.
That's fantastic. So thank you for the presentation. No need to give any introduction for this project. My question, as the site is located near to dam and region being seismic prone area, any special seismic analysis performed?
Yeah, the special seismic performance means the government of Gujarat has given a report on the seismic study of the particular area. So they themselves have given the report. And now based on the report, the report recommended to use zone 4 instead of zone 3 for the design. And then the same thing is carried out in our design.
Right. Okay. Then Arif Mizar is asking, do we have expansion joints in the core of the structure? If not, how do the temperature stresses are managed? How are the temperature stresses managed?
No, there is no expansion joint within the core. It's just a slender element, so it can expand vertically. So there is no problem. So what we did is to take care of the vertical shortening, column axial shortening of the core. So we actually monitored, we calculated what will be the axial shortening from the design, and then we have given that provision. So in the final pour, we had to check that level, and then whatever is extra concrete required, let us say 25 millimeter or 50 millimeter to take care of the axial shortening, that was taken up. But since it's a vertical element, it is free to expand. There is no other expansion joint given.
Right, absolutely. Then there's another question from Mr. Rao, and he's asking for structural stability. Was an analytical study done before the wind tunnel test? How did it match with the wind tunnel test results?
See, we did two tests. One is a desktop study. The desktop study was done by RWDI, and subsequent to the desktop study, we did the actual wind tunnel study, and they were both coming closer. And finally, as per the design requirement, we have to use the wind tunnel study, and then we have used it. And for your information, the wind pressure for which it was designed, the cladding panel is 6 kilonewton per meter square. The cladding panel is designed for 6 kilonewton per meter square unfactored.
Wow.
But that was the wind pressure for which it was designed.
Wow, that's fantastic.
600 kg per square meter is the wind load.
Yeah, it's quite high actually. So yeah, that's pretty interesting. In fact, so I'll probably just go for this one last question to you. I'm mindful of the time. We are already 7-8 minutes above our schedule. So I'll just take this last question and probably we'll conclude. The question is there any chance to have a similar technical video at the exhibition hall? It has a potential to inspire a lot of young engineers and students.
You mean to say any video in the exhibition hall there?
A technical presentation like this is what is requested.
No technical presentation where in the museum below the statue?
Hall. Yes.
I think there are a lot of technical presentations provided there. There are videos. The video which I played, 7 minutes video, is already there is part of the display. Maybe next time when he goes, he can check once again.
Yeah,
possibly. Information.
Yeah, absolutely. So I think the questions are still pouring in. I think we'll never find enough time to really answer all the questions probably today. But then, Mr. Sasidhar, thanks a lot. It was a fantastic presentation. I loved it. I'm very sure all of our viewers and attendees have also loved it too. So thanks a lot for doing this for us. And I hope that we'll have another presentation on a similar such wonderful project L&T is doing in the future as well. I thank all the attendees who joined us today. With that, we probably conclude the session today. Please, those who are IC members, and we have a follow-up December meeting that I've scheduled, the general meeting for the IC members specifically. So if you're an IC member of Mumbai, feel free to just stay on. I would request all others, we conclude over here, and thanks a lot for joining us.
Thank you for giving opportunity, Mr. Rajesh. And I only request, if someone wants any clarification, maybe if they don't have my email ID, they can write it to you.
Sure.
If you pass it on to me, I will reply.
Definitely. So those who need further clarifications, technical clarification, just write to me. You already have my email address. I'll be more than happy to pass it on to Mr. Sasidhar, and I'm very sure that he will be able to. Thank you very much.
Thank you.
Okay. Bye bye. Have a nice day.